righty. So yesterday, just so you guys review real quick what we talked about yesterday. If you were absent yesterday, you can go back and watch the part 1 video. But real quick, remember, in order to add or subtract radicals, we have to have like radicans. So 1 4 through to 10 plus 7 4 through to 10 is 8 4 through to 10. Here we made these into radicals and said that's 2 times the 5th root of 8 plus 10 times the 5th root of 8, so that was 12 5th root of 8, or you can write it using rational exponents. Here we had to break up the cube root of 54, and then I got like terms. Did I send over copies?
I guess so.
Huh. Interesting. I don't remember that. Thank you very much. All right. Appreciate that. That was heavy. All right. So break up a cube root of 54 to perfect cube, and then they become like radicans. Same thing here. Okay. Then we talked about here.
Good afternoon. Please excuse the interruption. All students that are taking an APEX online course second semester, please make sure your attendance has been taken and bring your laptop to the SOC, please.
That's right. Here's the
After your attendance, bring your laptop to the SOC, and it's only for students who are taking a course second semester. If you're in a full year course, you do not need to attend. If you took a first semester class and you're taking a second semester class, you do need to attend because we're going to enroll in the classes today. Thank you.
Okay, so the second thing we learned was we talked about if we have the cube root of x, if you have 3 x's, you're looking for groups of 3 to come out. If you have negative cube root of x, you can think of that as the cube root of -1, which is -1 x or negative x. Then we talked about the 4th root of x to the 4th, and we said, well, you can pull out one group of x's. However, you can't take the 4th root of the negative. And since x could be any number, you have to say, hey, got to be non-negative. So absolute value. But when we did the 4th root of x to the 8th, we said that is 2 groups that come out. So it's x to the 2nd power. Anything multiplied by itself, a negative times a negative would be a positive. So we don't have to worry about that being absolute value. Then we went here and we said, okay, cube root of 64, y to the 6th. We just broke it up. Cube root of 64 is 4. Cube root of y to the 6th is y squared. Split these up. 4th root of x to the 4th is absolute value of x. 4th root of y to the 8th is y squared. Again, didn't need to worry about the absolute value. And we did 2 more very similar to that. Then we were here and we said, okay, 4th root of 16 is 2. 4th root of 8 to the 7th. If you have 7 a's, you can pull one group out, 3 left underneath. If you have 11 B's, you can pull 2 groups out, 3 left underneath. 4 C's, 1 group comes out. We rearranged our outside numbers in our radicans. This one, if you were Drew, you didn't get this one done because we didn't do that in this class, but this was the hard one. Again, we said, okay, I need to pull a groups of 3. I had 8 of them. So I had to give it 1 more. That gave me y to the 9th on the bottom. So since I gave it 1 on the bottom, I had to give it 1 on the top. So I had x cube root of y over y to the 3rd. And that was where we left off. Am I correct? Okay. So now we're going to go to example C. And on example C, it says 14 x, y to the 1/2 over 2, x to the 3/4, z to the -6. Just like when we did these with whole numbers, there's so many different ways you guys could approach this problem, okay? I like to personally get my x's all, like, here. Let's do this. What can you guys do with 14 over 2? Those are numbers. It's not x to the 14th over x to the 2nd. It's 14 divided by 2. What's 14 divided by 2, everybody? 7. So I have 7. Now I'm going to look at the x's. I have x over x to the 3/4. What's my invisible exponent on that x? 1. So what math do you do with the 1 and the 3/4? subtract. So when you subtract 1 minus 3/4, what do you get? X to the what? 1/4. Can you do anything with y? Does it y have anything to combine with? Does it have a negative exponent? No, so it's fine. Leave it where it is. It's on the top. Leave it on the top. Now, z is on the bottom, but it's negative. Do we like it where it is? So where's it going to go? To the top and become z to the just 6. Not 1. Do you see why, AJ, it's not 1/6? Okay. Questions on that one? Okay, last couple. Perform each indicated operation. Oh, that's right. Remember, when it says assume all variables are positive, like it did here, you do not have to worry about your absolute value. Back here, it did not say that, so that's why we had to worry about the absolute value. Here, it says assume all variables are positive, so we're good. You guys should be done with this one. What's 5 squared of y plus 11 plus 6 squared of y? I hate my mouse with my brain. All right, are we good there? Did you already get these done? Mm-hmm. How'd you get them done?
Last night I did them. Because I did them.
You are amazing. All right. All right. How about this one? All right. First thing you have to do is ask yourself, can I simplify? Let's look at just this left side piece first, the 12 cube root of 2z to the 5th. Down here, I have 12. I have the cube root of 2 and the cube root of z to the 5th, which is 5 z's. Can I simplify cube root of z to the 5th? Yeah, how many can you pull out? How many groups? 1. So I'm going to put that with the 12. And now what's left underneath with the 2? Z what? Squared. Do you guys see how I did that? Okay. Minus. Now over here I have a z on the outside. And then I have the cube root of 54 and the cube root of z squared. What can you guys break up the cube root of 54 up into such that 1 is a perfect cube? 27 and 2. Okay, and then can we do anything if I have 2 z's here? Do I have enough to take a group out? No. What's the cube root of 27? 3. And then these are both underneath. So how would I write this the proper way? I have 12z cube root of 2z squared minus, what do you have here? 3z cube root of what? 2z squared. Okay, so what do you guys get? First of all, can you subtract them? Do you have like radicals?
Yeah.
What's 12z minus 3z? 9z. And then what's your like radicand? Cube root of what? 2z squared. Perfect. All right. You guys do these too. How am I supposed to know which ones are his? Oh, I have another box. Okay. All right. We done? No. Jack, what'd you get for the first one?
8 cubed y.
8 cube root of y. Yep, good. We're done. That one was easy. Green, I called on you yesterday, didn't I? Yeah. Landon K. I didn't call on you yesterday. All right, Landon. I have 16. I have the fourth root of 3, and the fourth root is z to the 6th. If you have 6 z's, how many can you pull away? How many groups of 4 can you pull away? One group of 4 comes outside, and then what's left underneath?
The 4 and then 2 z's.
Not 4, 3 and 2 z's. Okay, are you guys good there? Now, I'm going to come off to the side down here to do this one. I have minus z, fourth root of 48, fourth root of z squared. What did you break 48 up into, Landon?
16.
16 and what? 3? And we don't have enough here to take away. So you have, what's the fourth root of 16?
2.
So you have minus 2z, and then those stay underneath. Do you guys see how we did that? You only have 2, you don't have enough to take away. So that becomes minus 2z, fourth root of 3z squared. Okay, so start by asking yourself, do I have like radicans? Can you subtract 16z minus 2z? What do you get?
14z.
14z, fourth root of 3z squared. And you're done. All right, so now we're done with the notes. And now you have the rest of class time, and I will open the garage door. You guys can work on this homework.
Yeah.